Mrs. Smith here. Heidi ho, neighbors. How are my mathematicians doing? Hopefully great. We are working on lesson 2.5 today. Scientific notation. Scientists like to use this stuff. Helps to define very large and very small numbers. We're going to go from standard to scientific, and then eventually we will go from scientific to standard. But our I can statement says I can take a regular number and put it in scientific notation. That's what we're going to do today. But first, we better talk about what is scientific notation. So scientific notation is a short way to write very large or very small numbers. And I'm just going to breathe numbers with the number sign. Okay? So, very large or very small numbers. When you deal with math or things in the science world, sometimes there are very large numbers, and there are very, very small numbers. And if you have to write them over and over and over again, you don't want to probably put in all those zeros or a decimal point in 0.00000000624. So therefore, they developed a way to write these very large and very small numbers. Okay. Some characteristics that you need to know. Large numbers have positive exponents. Now you know why it's in this chapter, because we're going to deal with some exponents. So, example, 2,300,000. That's a pretty large number. I'd love to have $2,300,000. Wouldn't that be awesome? Oh boy, where do we spend it? Okay. Small numbers have negative exponents. Oh, there's that exponents again. That's why it's in this chapter. Okay, and that would be a number like 0.0032. This isn't even 32 cents, and we know 32 cents isn't very much, especially when we're comparing it to $2 million. So this is less than, this is 32 10,000ths, so a very, very small amount. Okay, also something else you need to keep in mind is it must be a number between 1 and 10. So that's going to be pretty important. It must be a number between 1 and 10. So scientific notation looks something like this. 7 times 10 to the third power. That's what scientific notation, ladies and gentlemen, looks like. Or 8.7 times 10 to the negative fourth power. Okay, so large numbers have positive exponents, small numbers have negative exponents. Now, this is a non-example. 87 times 10 to the fourth. Now, hopefully, you realize it's a non-example because of this I just wrote right here. It must be a number between 1 and 10. And look at that number. Is 87 between 1 and 10? It is not. So that's why it's not an example. All right, how about this one? 3.2 to the negative third power. What are they missing? 3.2 to the negative third power. Well, if you noticed, both times it had a times 10 and a times 10. Scientific notation always has that times 10. So it's missing that times 10, and then that would be to the negative third power. There is a difference between 3.2 to the negative third power, and 3.2 times 10 to the negative third power. So there is a difference between those two things. All right, and we could put it in our calculator and check that out. So to write numbers from standard notation, which standard notation is just fancy for a regular number. It's just fancy way to say regular number. To scientific notation, this is what you're going to do. You're going to move the decimal to get a number between 1 and 10. Step 2, you're going to write times 10. Put that in your notes. And then number 3, count how many times the decimal moved from its old location to its new location. So how many times did it move from its old location to its new location? You write that number as the exponent on the 10. Note, if the number is large, the exponent is positive. If the number is small, less than 1, starts with a decimal point, that's what we're talking about, the exponent is negative. All right. I have a lot of students that love these once we get it going because I think you'll find that they're fairly simple. They're pretty easy. So here we go. Number 1. 6,500. Step 1 is to get a number between 1 and 10. So I have to put in a decimal point. I'm going to put in a decimal point somewhere where it would make a number between 1 and 10. Right now, I can't see my decimal. If I can't see my decimal, it's always at the end. Oh, right there. So if you can't see your decimal, it's always at the end. So right now, this is 6,500. If I were to make it a number between 1 and 10, I'd put my decimal right there. And my number, not including the zeros, just the numbers that count, would be 6.5. 6.5. Okay? That's step 1. You're going to stop the zeros because our whole point is it's a shortened way to write a very large or very small number. So when the zeros start repeating, I get rid of them. Then I write, step 2, I write the number times 10. And then what I need to do is I count how many times the decimal moved from its old location, right here at the end, to its new location. So now it's located here. And you write that number as the exponent on the 10. So it moved 1, 2, 3 times. So on the 10, I write that it moved to the third power. And 6,500, that's a pretty large number. So it stays positive. And that's it, ladies and gentlemen. That's all you need to do. So let's do number 2. So 291,000, pretty big number. Okay. We want to shorten it up, so we want to get rid of those zeros. That's essentially what scientific notation is all about. When the zeros start repeating, that's when we can get to drop them off and shorten up how we write it. So if you can't see your decimal, it's always at the end. There it is. And I'm going to move it between the 2 and the 9 because that would make it a number between 1 and 10. Now, I keep writing until the zeros start repeating, and then I don't have to write those anymore. So 2.91, that's 2 and 91 hundredths. That's between 1 and 10. Step 2 is write times 10. And now I count how many times it moved from its old house. 1, 2, 3, 4, 5 to its new location. And I put it on the exponent on the 10. Okay? All right, so let's write an even larger number. So I am talking 930 million. 930,000,000. So if you can't see your decimal, it's always at the end. Right there it is. And you're going to get a number between 1 and 10. So your 1 and 10 would be 9.3. Once the zeros start repeating, I can cut those off. I don't need them anymore. I'm going to carefully erase this here, though. There we go. Because now I need to write times 10. And I count how many times did it move from its old location to its new location. 1, 2, 3, 4, 5, 6, 7, 8. And of course, 930 million is a very large number. Okay. What about something like this, number 4? What if I have 83.2000 like that? Okay. Now, I see my decimal this time, but I still need to get a number between 1 and 10. 83, if I left it like that, where this decimal is right now, is not a number between 1 and 10. So I'm going to move my decimal to here, and it'd be 8.32. When the zeros start repeating is when I can cut them off. Now I write times 10, and I have to say how many times did it go from its old location, that's where it was here, to its new location. So to the first power. So 8.32 times 10 to the first power is what you write. Okay, so now we got to talk about some small numbers. We've talked about large numbers, so let's talk about small numbers. Small numbers means it's less than 1. It starts with a decimal point. So it'd be something like this, decimal point. Let's see, 0, 0, 0, 0, 0, 0, 8. So 6 zeros and then an 8. Ooh, doggy, that's a small number. Same rules apply. I see my decimal point, but I need to get a number between 1 and 10. I would put my decimal point after the 8. Don't put it before the 8 because that's not a number between 1 and 10. That's like 80 cents if you were thinking money. And 80 cents is not between $1 and $10. Okay? 80 cents is below $1. So it'd be after. So it'd be 8. And you could put the decimal point here, although you don't have to. Write times 10. And then 1, 2, 3, 4, 5, 6, 7. But when it's a very small number and it starts with a decimal point, what did it say to do? It said to make the exponent negative. So I have to make it negative. So it'd be 8 times 10 to the negative 7th power. Okay, let's try another. Number 6. Decimal point 0, 0, 0, 3, 6, 5. Okay. So get a number between 1 and 10. That would be right here. Now I have to include all the numbers. So 3.65. I write times 10. And then how many times did it move from its old location to its new location? 1, 2, 3, 4. But it's a very small number because it starts with a decimal point. So it'd be negative 4th power. Okay. Here we go. Number 7. Decimal point 0, 0, 0, 0, 9, 2. So, I see my decimal point, get a number between 1 and 10, so it'd be 9.2. Your job is to drop those zeros, so how many times did it move? 1, 2, 3, 4, 5. So I write times 10 to the negative 5th power. All right, last one, number 8. 0.03409. Get a number between 1 and 10. This one doesn't get shortened very much, 3.409. Now I can't drop that 0 because it's in the middle of the numbers. I can only drop the numbers or the zeros that come before it or the zeros that come after it in those cases. So 3.409, I write times 10, and then how many times did it move? 1, 2, but it started with a decimal point, so it'd be to the negative 2 power. So there you have it, standard notation, which is just fancy for regular number, to scientific.